uh, if we are talking about the definition of the electric power, then electric power is the rate of work done. Okay, electric power is the electric work done per unit time. Hmm? So electric power is electric work done per unit time. So electric power we will represent with P, and electric power, oh, this is electric power. This is given by work done divided by time taken. So electric work done per unit time, you can write. Electric power is electric work done per unit time. So power can be represented by P, work done is W, and T is the time. Okay, now unit of power, SI unit of power. See, power is work done divided by time. Unit of work done is joule, unit of work is joule, unit of energy is also joule. So unit of work is joule, unit of time is second. So joule per second. And this unit is also known as watt. This unit is in the name of a scientist, James Watt. Okay. Okay. So there are some formulas for calculating the electrical power in electrical circuit in terms of the current and potential difference. So those formulas we will discuss. Okay, those formulas we will discuss. So first formula for calculating the power. First formula for calculating the power. Hmm. Power P is given by potential difference into current. Hmm. What is V? V is the potential difference, and I is the current. Current will flow in the wire, so it will be current. Okay. Another formula, power is equal to I square into R. Okay, you can derive with the help of, when you will put V is equal to IR. Okay, in this equation, when you will put V is equal to IR, see, you have this expression now, P is equal to VI. And you know that, just a minute, Azaan is going on, so V is equal to IR, we know. Now put value of V here. It will be P is equal to V. In terms of V, you will have I into R and multiplied by I. So what will be the formula of the power? I square R. Second formula. Okay, this is first. First, second, and third formula also you can drive. How you can drive? You know that P is equal to I square into R, and you know that V is equal to IR. Now from here you can get I. So I is equal to V by R. Put the value of I in this equation. So it will become V by R square multiplied by R. So it will be V square divided by R square multiplied by R. One R is cancelled with one R. So the power will be V square divided by R. So three formulas you have to remember. Definition you will not get. You will get the questions, numericals. Three formulas of power. VI, I square R, V square divided by R. Okay. Accordingly, we will use these formulas. According to the situation, we will use these formulas. Now we will solve one question. This question. The question from NCERT. So they are saying an electric bulb is rated 220 volt and 100 watt. There is an electric bulb. Okay, this is a bulb. And the potential difference 220 volt and power of this bulb is 100 watt. Generally we say na, in our home the bulb is of 20 watt, 30 watt. That is power of that bulb. The electric bulb is rated 220 volt and 100 watt when it is operated on 110 volt. The power consumed will be. They are saying when this bulb, okay, when this bulb will be operated, means this is the rated value given and this is the supply voltage to the bulb. Okay, this will be the maximum amount of voltage for this bulb. Okay, so this is the means this bulb is operating at 110 volt, means you are giving 110 volt to this bulb. They are asking power consumed will be. Very easy. This data is given data. There is one formula of power. P is equal to V square by R. From here, can I calculate R? Can I calculate the resistance of this bulb? V square by R, V square by P.
Yes, sir.
So basically, na, whenever this is given, this is the rated value, means when you will purchase the bulb from the market. So on the cover of the bulb, okay, you will get this value written there. So with the help of this value, you can calculate the resistance. So V square by R means 220 multiplied by 220. V square by P, power is 100. Cancel out, cancel out. 22 multiplied by 22, I think 484 it will be. 484. 22 and 22. 44 and 44. 484. Okay. So resistance is 484 ohm. Now you have the resistance here. Can you calculate the power now? P is equal to V square by R. Hmm? So V square, what is the voltage you are giving to this bulb? 110. What is the resistance? This cancel out. Oh, what I'm doing. Now cancel this with 2. Okay. So it will become 2, 4, 2. It will become 55. Now cancel this again. 1, 2, 1. It will become 55. So now it can be cancelled. 11 11 the 121 and 11 5 the and 11 5 the it will be 25 watt. The power will be power consumed. This is the power consumed. And what is this? This is the rated power. Rated power means the maximum amount of power the bulb can take. So this is power consumed. Simply you have to apply the formula and get the answer. So what will be the answer? D option. Option number D. You can take this question also. Which of the following does not represent electrical power in circuit? Tell me the answer. Very easy.
Yes, sir.
Tell me the answer. Answer of
Acha.
this question. Three formulas, no? There are
Yes, sir.
VI, I square R, P square by R.
Sir, IR square will be wrong.
So this is the answer. Okay, so write down fast. Then we will move to energy.
Sir, scroll down, please.
Done.
Yes, sir.
Completed.
No, just one minute.
Okay, 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 fine.
Done, sir.
Okay. So no need to write this question. Okay. Uh,
Okay, sir.
Now I will discuss the electric energy. Electric energy, we know what is electrical energy. You are giving the electrical energy to your laptop. That is why your laptop is running. Means I am not saying that running, working. Now, how to calculate electrical energy and what is electrical energy? Electrical energy is the product of the electric power multiplied by time. Electric power multiplied by time. For example, suppose there is a bulb of there is a bulb, and that bulb have is consuming 100-watt power. 100-watt power the bulb is consuming. Now this bulb is working for, or you can say this bulb is glowing for 5 minutes. So in this scenario, if someone is asking how much electrical energy is spended by the bulb, so electrical energy spended by the bulb will be the power multiplied by the time for which the electric bulb is glowing, 5 minutes. But you will convert minute into second, so it will become 100 multiplied by 300, so it will become 3 into 10 to the power 4 joule. So basically, what is electric energy? E. Electric energy is power multiplied by time. Power multiplied by time. Simple. And unit of energy is joule. Okay, unit of energy is joule. If somewhere written 1 kilojoule, it means 10 to the power 3 joule. Now there is one more thing here. This is very simple. Electric energy is electric power multiplied by time. P is electric power. Now, one thing is there, commercial unit of electric energy. Now, we know that the SI unit of energy is joule. But in general uh, life, in our home, all that, we use a lot of power. Not in joules. We use not a power. We use energy not in joule. We use a lot of energy, large amount of energy we use. Suppose a heater is placed here, that heater is taking uh, 800 watt. Okay, 800 watt of power is taking, and if I will multiply that power with time, I will get large amount of energy, because generally in our home the bulbs, heaters and all that running for long period of time. So basically what I want to say, for the commercial purpose in our homes, in hospitals, large amount of electric energy is consumed. So there is a commercial unit of energy used. We use another unit of energy, that is commercial unit of energy, that is bigger unit as compared to joule. So write down the commercial unit of energy. Commercial unit of electric energy is kilowatt hour. Kilowatt hour. Okay. Now we can convert 1 kilowatt hour into joule per second. What I told you, the unit of energy is mm, we can convert this 1 kilowatt hour, into joule, because kilowatt hour is a bigger unit of energy, so we can convert this kilowatt hour into uh, joule. Okay, so convert it, 1 kilowatt hour. So 1 kilowatt, first convert this kilowatt into what? 1 kilowatt, in 1 kilowatt there are 10 to the power 3 watt. 10 to the power 3 watt. Now multiplied by, in 1 hour, this is hour, in 1 hour how many seconds are there? 60 into 60, 60 seconds. Okay, so you have 6 are 36 multiplied by 10 to the power 5 watt second. Now see here, the electrical energy is power into time. Unit of electrical energy is what? See, electrical energy is electrical power into time. So unit of electrical power is what? And unit of time, SI unit of time is second, watt second, and watt second is joule. So basically what we are getting? 36, or you can write in this form, 3.6 into 10 to the power 6 watt second is joule. So in 1 kilowatt hour, in 1 kilowatt hour, 1 kilowatt hour, how many joules are there? 3.6 into 10 to the power 6 joules. So this conversion you should know. This conversion you should know. Write down fast, then we will solve numericals.
Done, sir.
Okay. What happened? Hmm. See this question. A refrigerator having power of 350 watt. There is a refrigerator having power of 350 watt, operates for 10 hours a day. Hmm? A refrigerator is operating in 1 day 10 hours. They are saying calculate the cost of electrical energy. Cost of electrical energy to operate it for a month of 30 days. Means they are saying in 1 month of 30 days, what will be the cost of electric energy? And the rate of electrical energy is 3.40 per kilowatt hour. Means if we are spending 1 kilowatt hour of energy, we have to pay 3.40 rupees. And kilowatt hour means, what is the meaning of kilowatt? What is the significance of kilowatt hour? In 1 hour, in if you are consuming energy of 1 kilowatt hour, so what does it mean? Means you are spending the energy of 1 kilowatt in 1 hour. That is the meaning of kilowatt hour. Kilowatt means power, hour means time. So in 1 hour you are spending 1 kilowatt hour. So basically, if you will spend 1 kilowatt hour of energy, you have to pay this much of rupees. So very easy question. Calculate energy. What is the energy spending by the refrigerator in 30 days in kilowatt hour? Then multiply that energy with 3.40. So in 1 day, so in 1 day, energy spent, energy consumed. Suppose E is the energy consumed in 1 day. And what is the formula of energy consumed? Power into time. Hmm? Power into time. Okay. Now they are saying in 1 day, the refrigerator is running 10 hours. So time is 10 hours for 1 day. And convert this 10 hours into second. No need to convert this 10 hour. Okay, so this is power into time. So power is equal to 350. And this will be the power in watt. Okay. And uh, actually, what you should do now? You should convert the power. Power is given as 350 watt now. Convert this power into kilowatt. So divide it with 1000, 10,000. So it will become kilowatt. Now directly you will get the energy in kilowatt. So it will be power into time. So power is 350 divided by 1000 multiplied by 10. So this much of energy, this much of kilowatt hour energy you have. What is the kilowatt hour energy? Means in 1 day, the refrigerator is consuming 3.5 kilowatt hour energy. Because this is kilowatt, this is hour. Another way to calculate the energy, calculate the power in SI unit, that is in joule. Calculate the power in watt, calculate and put the value of the time, in second. So you will get the energy in joule, then convert that joule into kilowatt hour. You know that in 1 kilowatt hour, how much energy is there? 3.6 into 10 to the power 6 joule. So you can calculate in 1 joule, there will be 1 upon 3.6 into 10 to the power 6 kilowatt hour. So in this way also you can calculate. So I am not going in that because when we can solve in an easy way, why to go this method? So we have this much of kilowatt hour energy in 1 day. This much of kilowatt hour energy in 1 day. Now in 30 days, energy spent energy consumed by the refrigerator will be this multiplied by 30. This is the energy in 1 day. In 30 days, 3.5 into 30. Okay. So it will be 10.5. It will be 105. Na? 105. So it will be 105 kilowatt hour. Now in 30 days, they are asking how much we have to pay. Means what is the cost of electric energy in 30 days? So cost of electric energy in 30 days will be the total energy multiplied, means if you are consuming 1 kilowatt hour, then you have to pay this much of rupees, 3.40 rupees or anything. If you are consuming this much of power, so you have to multiply na, to get the total amount. So you will get 3.40. This is simple mathematics. 105, and when you will multiply, you will get the answer 357. 357 rupees. I am not saying this is rupees. This can be res 375 RS res. Okay. Write down.
Let's scroll down.
Finish this. Finish. Okay. So now we will discuss the Joule's law of heating. So what is Joule's law of heating? Means suppose you have taken any wire, and in that wire the current is flowing for some time. Then in of wire there will be some resistance. Now if the current is flowing in the resistance, then the temperature of the wire will increase. So the wire will become hot. Okay, if you want to check now, you can check uh, your laptop from the side where the fan is. So you will see there that part of the laptop will be hot. Why this is happening? Because current is flowing, and through the wires, okay, so through the wiring system of the laptop the current is flowing, and due to the resistance of the wiring system, heat is produced as the current flows. Okay, so Joule's law of heating is basically can be explained in this way. If suppose this is a wire, and in this wire the current I is flowing, and R is the resistance of the wire, and This current is flowing for time t. Then heat produced in the wire. What is I? I is the current. I is current. R is the resistance of wire. And I is the current flowing. And T is the time. Then heat produced in the wire is given by I square RT. Okay. And this will be in joules. So, and what is H? H is heat produced in wire. So this is Joule's law of heating. Whenever the current flows in a wire, the wire becomes hot or heat is produced in the wire. Okay. So you can write one statement also. Mm, When electric current is passed through a high resistance wire, the wire becomes hot, very hot, and produces heat. Okay. This is known as the heating effect of current. If someone is asking what is Joule's law, then you will say H is equal to I square RT. If someone is asking what is Joule's law of heating, then you will give this statement. Oh, oh. Okay, write down. So one more topic is left in this chapter, and after that, this chapter will be finished. Application of heating effect of current. After this, we will start magnetic effect of current.
Done, sir.
Okay. Calculate the heat produced when 9600 coulombs of charge is transferred in 1 hour through a potential difference of 50 volts. Okay. So basically, in this question, you have to apply this formula. H is equal to I square RT. So how you will calculate uh, current? I told you what is current. What is the formula of the current? In the beginning, I told you current is equal to charge divided by time. So charge is given as 96000 coulomb, and time is